All right. Thanks to all of you who are still here after a long day of talks. Thanks to Alan for organizing this session. My name is Luca, and I am a scholar and a professor at the Technological University Dublin in Ireland. And with some colleagues, we have produced this manifesto that was just published a few weeks ago. So as you know, and as you are here, the field of the explainable artificial intelligence has seen significantly grow in the past few years. Everything is really exploding now. And it was a niche research topic within artificial intelligence, but now, as you can guess, it's a very active field of research. And all these talks today are pointing to a very specific things, which is explainable artificial intelligence is really multidisciplinary, interdisciplinary, and transdisciplinary field. In fact, we are here, all of you probably, most of us are from computer science, engineering, maybe I met some biologists and psychologists here, some neuroscientists, and of course with ethics there are a lot of philosophers. And because of this interest, there is now a specific World Conference on Explainable Artificial Intelligence that I founded last year, and this year, as we are in the second edition, it's for open to scholars submitting papers and also open to industry partners. It's going to be organized in Malta from the 17th to the 19th of July in beautiful Valletta. We are reviewing the first batch of manuscripts submitted to the main track, which will be published by Springer. And the late-breaking work tracks and demo are still open, so if any of you would like to participate and submit some late-breaking work, it's still open. We have roughly 300 professors as part of the program committee, and probably some of you, Professor Rita, Alan, and are participating in this conference. We have got support from Women in AI and a couple of startups and Malta Digital Innovation Authority is not really a startup, but this means that we have the support from the state there in Malta. So you're welcome to join. This was the manifesto that we published with 19 professors worldwide. Really, we touched probably 12, 13 countries from Japan to Europe to America. And is exactly as the title of this talk, Explainable Artificial Intelligence, XAI 2.0. I think we are evolving as a field, a manifesto of challenges and interdisciplinary research direction. This was published really 4 weeks ago. As you have seen today, XAI is a very broad things. We have heard from our colleagues some technique that are mainly postdoc. Some of them are model agnostic, some of them are model specific. As for example, Venitra was mentioning, there are also anti-hoc interpretable design options. Then we have global and local scope. We have applied this to regression or classification tasks. We have, as Claudio or Timur has mentioned, we can manipulate very different types of data, images, pictorial, textual, time series, and we have also a set of different output formats, so we can play with attribution methods and end up with rules, with the numerical. As Professor Bologna said, with rules, we have textual, visual, and mixed multimodal explanation. We have seen some example in healthcare with Professor Bologna, in finance, with the Timur, as far as I remember. We have a lot of application nowadays in agriculture and in education, but just reductive. So this, the manifesto, we have found 28 problems which we categorize in 9 categories. I'm not going through each of these in details because otherwise we stay here until tomorrow. We are all tired. So I am going to quickly go through this, and my goal is to trigger something in your mind, and when you walk out this door, you remember some keywords, and then maybe we can continue the discussion online or... So the first problem is creating explanation for new types of AI. Nowadays, there are a lot of large language model, the GPT family, the diffusion model, and this is a problem. We don't have access to ChatGPT. We don't have access to those large models. So what are the solutions we have identified with my colleagues? For example, we can resort to mechanistic interpretability, which is a sort of reverse engineering of neural networks. Or we can start thinking about incorporating some notion from information geometry. The second problem is that we need to create explanation for distributed and collaborative machine learning. That means sometimes we need to train models over multiple servers, multiple computers, and imagine how we're going to produce the explainability of these little surrogate models distributed. So one of the solutions is to focus on multi-party computation. So for example, we can produce local explanation on our machine, and then we can update globally the explanation on the overall model. As I think Claudio said, we can also apply protocols from distributed system, for example, in this case, distributed cryptography. The second problem is improving current XAI methods. For example, we have Timur, Claudio, Professor Rita, all looking at autoencoders, and some of you also mentioned LIME, SHAP, layer-wise relevance propagation. Those are all XAI attribution methods, and each of them have their own limitations. So how can we look forward and do a kind of portfolio and use parallelly this XAI method? And maybe we can apply a voting mechanism that takes the output of each XAI method and combine together to have something a little bit more precise. Or we have a problem of augmenting, improving concept-based learning. For example, from the autoencoders, we can try to extract concept from the embedding from the latent space. The problem is that these embeddings usually are not really human understandable. So we need to play with concept of abstraction. But for example, someone resort to use prototypes. So the prototypes of a cat, the prototypes of a dog. But extracting concepts that are human understandable is not any of these things. So what we can look at is to the integration of neurosymbolic paradigms. So for example, we can use concept-based learning, which is what we are doing with autoencoders. We train neural networks, and then we can apply some symbolic techniques, for example, rules or knowledge graph, to augment what we learn thanks to deep learning and not lose its power to something that is more explainable for humans. As I think Timur said, we have the problem of artifacts, and sometimes we need to resort to synthesis-based explanations, so we can use the decoders of the autoencoders to reconstruct the inputs, or we can use generative adversarial networks. But again, producing interpretation, explanation out of these black boxes is not a trivial thing. So we can do, for example, play with the distortion analysis, and we can play with synthesized reference. That means we have a reference which is the output we expect, and we see from the embedding space, from the latent space, how distorted our output to the input. And then we have the problem of creating robust explanation for human. And in fact, the postdoc methods that we have seen today, they work, but they are fragile to input perturbations. So how can we try to solve this problem? We need to start focusing on producing benchmarks, either on the methodological side, methods, but also producing data set. And then we aggregate explanation, for example, as Vinitra said, model explanation, and we can do model. We can pay attention to the property of model inversions, to the attack of our models, and we can play with the concept of reveal to revise. I think, as Prof. Guido was saying, we train, we compute the fidelity, and then we try to retrain to improve the fidelity. So reveal to revise. The third problem the third class of problem we identified was the clarification of the use of the concept and notion in explainable artificial intelligence. Interpretability is something, explainability is something else. So one of the problems is exactly elucidating the main concept and notions surrounding this emerging field. How can we do that? We still need to improve the constant explicit definition of all these notions: interpretability, explainability, fidelity, or robustness. Create a dictionary of these, let's say, local, domain-dependent, user-dependent explanation, and try to find an agreement. And by doing this, we can enable fairer comparisons. We need to clarify the relationship between XAI as a field and trustworthiness. Trustworthiness is something that we expect, but if we think how can we actually measure trustworthiness, is not something that is very easy. Or we look at trustworthiness as a property. So trust is an ill-defined concept in psychology, so we try to model that concept. Or we can look at trustworthiness as a requirement, for example, from governments, from the final stakeholder, what they mean by trustworthiness, and then we can take this as a target. Then we need to find a useful account of understanding what are explanations. As you can see, it's not something that is commonly agreed. So we can take, we can be inspired by what's happening in psychology and philosophy, and start reasoning on the concept of explanation. If I don't remember who was before me, how can you define explanations? Well, I think Alan said that. We define explanation. We come up probably with 100 different definitions. The first class of problem we identified is evaluating XAI method and explanations. So the goal is to facilitate human evaluation of explanation. How can we evaluate explanation produced by our XAI methods? So we need to involve users. So we need to start thinking how to perform empirical user-centric research. And here we need to leverage knowledge from computer science, but also we need to involve psychologists, because they are close to the definition of explainability, but also the impact of this for the social sciences, for example. We have a problem of creating an evaluation framework for XAI methods. SHAP, LRP, saliency maps, all those XAI methods are playing alone. They are individual trains of methods. So what we can do is to create a pipeline to evaluate the explanation provided by each of these XAI methods. And close to the concept of benchmarking, we need to try to find a data set that we can use as form of ground truth, independently on the underlying XAI method we will be using. And this will allow comparison across methods. For example, as they have done with Quantus and Clever XAI, you can download those things. Overcoming limitation of studies with humans. For example, sometimes we don't have enough users we can use, for example, in healthcare. If we need to, I don't know, do some XAI study on fMRI scans of babies, we don't have many babies. So our underlying data set is limited in size. So sometimes we need to resort to the generations of generation of synthetic data. But then we can augment this concept by collecting data with virtual participants. as what Claudio was mentioning, he was playing with the concept of agents. So we can play with AI-driven agents or personas. So then the fifth problem we identified, the class of problem, was supporting the human-centeredness of explanation. How can create human understandable explanation both for expert but also for the layperson? The layperson, we cannot expect the layperson to understand what an autoencoder is. Solution is to both use local explanation and global explanation. Someone, don't remember whom, defined this as glocal explanation. Or going close to the notion of rules, we can use also the notion of argumentation. We can use logic and reasoning. And it's connected with our previous integration of neural paradigm for learning and symbolic paradigm for logic, neuro-symbolic reasoning. We need to facilitate explanation with concept-based explanation. Why concept? Because concept is something that is more digestible to human. We can process concept. We can't process easily number or probabilities or logical axiom and so on. How can we solve this problem? Defining concept and creating a taxonomy of concept. And then from this taxonomy, we can start picking things and, for example, enabling the personalization of explanation that are concept-based to certain categories of users. We need to start thinking about how we can address the explanation, the divorce of explanation from reality. Artificial intelligence is really becoming way more complex, and we might have a reality drift. We might have very complex model that they learn something that is not even interpretable by the engineer, and therefore not even explainable to humans. So we need to pay attention that whatever we learn does not deviate too much from the human reality. Otherwise, I think we let the machine taking advantage. How can we solve this? Playing with the concept of falsifiability, explanation falsifiability, or including the notion of ontologies. Why? Because ontologies are created by humans. There is a quality check by humans. So if we play the terms injected in an ontology, we can play safer. These also enable local controls of what we build and guarantee us that the explanations are understandable by human, and we respect the human understanding of the reality. Then we need to focus on uncovering causality for actionable explanation, because sometimes we produce what we call explanations, but they are not actionable. We cannot actually use for decision making, for supporting decision or recommendation. For example, as I said, introduce the concept of counterfactual. How can we do this? For example, we can use a large language model for producing the counterfactuals and start playing with some notion of proximity, plausibility, diversity, sparsity, and feasibility. But also we can use automatic causal graph for model. Causal graph, the notion of graph is more interpretable and explainable to humans. The sixth category of problem we identified is supporting the multidimensionality of explainability. Explainability is not an easy concept to model, is multidimensional. So how can we create multifaceted explanation? Not only for technical interpretability, so not only to explain precision, recall, error, probabilities and everything, but also including other metrics. For example, we start including the metric of trustworthiness, which is connected to safety, accountability, fairness, and other metrics for justifying the inference of a model we train. And also we need to start playing with the trade-off between technical metrics and trustworthiness metric, because we might maximize accuracy, we might maximize precision and all those, but we might minimize trustworthiness, we might minimize safety. Who cares if a model is 99% accuracy if it's not safe? So there is this trade-off between technical metrics and, let's say, trustworthiness metrics. And then start really, to solve this, probably we need to start thinking what explainability means as a construct. So we need to ask a psychologist, can you define explainability? It's like a love. Can you define love? You cannot define love. You have your own definition of love. But if you go to psychology, to the field of psychometrics, then we can start thinking the way to model love, in this case, explainability. We need to start collaborating and enable interdisciplinary work in XAI. Now we are scattered. Computer scientists are paying a lot of attention about training in neural networks. Philosophers of ethicists just play with the concept of safety and all those things, but they don't know how a model is trained. And so we need to start cooperating, creating a domain-independent. They are domain-independent and term-specific. So how to solve this? Let's try creating collaborative platform, standardized terminology, glossaries. I don't know where we can find all these things yet. Let's start building forum exchanges. Let's start creating a repository where all of us can integrate our own ideas, and each idea might contribute to an agreement, to a definition of something. We need to adjust the XAI method and explanation for stakeholders. Each stakeholder has different attitudes, different preferences, different background, different abilities. Engineers are a type of stakeholders. People working in governance are different type of stakeholders. So as Vinitra was mentioning, let's start using, for example, multimodal XAI methods. Why? Because I might understand better numbers, but maybe people who don't work in computer science might better understand images, science maps. Or we can start focusing on the way we train data, and we can start using ontologies. Also, something that is really emerging is the notion of interactive explanation. Explanation might change over time. And also, if we have a tool to interact in an explanation, then we might have a better grasp of what's going on at a global level of a model. And then this means the notion of human in the loop. Let's put the stakeholder in the middle of this. Adjusting explanation to different domains, self-driving cars, healthcare, finance, they are all coming, they have all different assumptions, and they have different expectations. What is required in finance is not required in healthcare, which is not required in education. In education, we might allow some more error. In healthcare, we cannot allow errors. In finance, if we allow an error, you can see the impact on loaning some money. So we can solve this with requirement-based explanation. We start from requirements, and then we build explanation. We start from the context, for example, standards and guidelines, and we start building explanation. And then adjusting explanation for different goals. This is a stakeholder-centric solution and an explanation strategy. We need to involve scientists, we need to involve regulators, we need to involve end users. As I said, now we are all working independently. I am almost there. Mitigating now the negative impact of XAI. Mitigating failed support by XAI. In medicine, if a model is trained with 99% of accuracy, the explanation reflects the models. But if the explanation are not real explanation, they can cause more damage than acting as a tool for explaining something. So we might have misleading explanation. Some colleagues suggested to introduce perorative explanation, which means beside having the motivational persuasive explanation, let's start building explanations that are supportive of an outcome, an inference, but also contrary to this inference. Let's start creating a better picture, pro and cons. We need to devise criteria for falsifying explanation. If we are open to falsifiability of explanation, then we are set to failure. Because we are not if I create an explanation and don't allow you to attack my explanation, maybe I'm hiding something, there is some bias in my reasoning processes, in my method. How can we enable a falsifiability? We can draw a parallel with the philosophy of science, cognitive science, and the epistemology. For example, we can use the notion of falsifiability of Karl Popper's, or we can use standardized protocols. We also need to secure explanation from the abuse by malicious human agents, malicious human. For example, employers can craft borderline plausible explanation of bias model just to avoid it. So how can we check if they are malicious or not? Well, we can resort to our concept-based explanation, and we start playing with the notion of the adversarial and non-adversarial example. But also, not only malicious human agents, but also super intelligent agents, because we might be able to create some very powerful artificial intelligence, some very powerful agent that can act maliciously, because the high complexity, for example, of future AI models we can build. And we want to understand this large language model. We know what they produce, but we don't understand how they work. They are so big that they might also act maliciously. And therefore, we need to resort to a portfolio of approaches. So we need to play with metrics coming from XI, but also metrics connected to safety. And eventually, the last problem, then I set you free, improving the societal impact of XAI. For example, now with the large language model, we have a problem of the originality attribution, the plagiarism detection. And this is real. All probably for those teaching in university, you have the problems as we have in my college. Students use ChatGPT to write code, to do summary. Who is the author of this? ChatGPT or the student? So we need to start thinking on reformulating the concept of authorship. Things might evolve, as in this case. And we can play with XI method to redefine the concept of authorship, at least for the AI-generated parts. We need to facilitate the right to be forgotten. For example, data owned by a particular user is unlearned by a large language model, might be unlearned by a large language model. So we need to start thinking of creating novel training technique with non-sampling around the forbidden data because of the GDPR. And then we can use XI method for identifying data instances related to the user. And eventually, we need to start thinking, and this will be a problem in the future, is addressing the power imbalance between individuals and companies. Because we are building unreasonable AI systems that maybe are not really fair and trustworthy. How can we solve this? Well, we need to start enabling participative design of artificial intelligence with XAI. So involving stakeholders from different background, with different expectation, computer scientists, psychologists, social scientists, ethicists, philosophers, people from governance, from finance, from healthcare. And so basically these are the problems that we have identified. It was 1 year of work with 19 people, and in the team we really had a computer scientists, philosopher, psychologists, ethicists, and it was, believe me, it was a year of disagreement. And we came up by putting this together after 1 year. So these are, of course, there are other problems connected to cybersecurity and many other things, But we try to give an overall synthesis of XAI as a field, and that's why we renamed this as XAI 2.0. Thank you very much for your attention. We have at least one question for Professor Longo. I might not be able to answer.
Hello, thank you for your very nice talk. It's a very comprehensive question. Do you have a hierarchy of where to start? Because if we want to address this field, we cannot go for the 9 categories in parallel. So any recommendation?
Let me go back 1 second. So this manifesto is published here, is open access. We pay a lot of time to make open access. And you can see this schema, which on the manifesto, and actually pages explaining each of these in details. It's not technical, so there you won't find any formula. It's very with text, and this is the starting point. And for those a little bit more nerd like me, this is a taxonomy that we publish with a PhD student. But anyway, there are a lot of review papers that you can find. But anyway, in this paper, actually there is a table that lists all the review articles that have been published in the last 5 years. There are like 25 review articles on XAI. Someone focuses on XAI in finance. Someone works in XAI and global explainability. Someone working in the output methods. Someone working in the notion of explainability. So this is the starting point that might help you start making sense of this jungle of things.
Thank you.
Any other questions? Okay, so let's thank you.
you.